This is question number, welcome to Honors Physics Podcast. This is question number 13 from chapter 18. We're given two identical particles and their separation, their release from rest. We notice that particle 1 has an acceleration of magnitude 4.6 times 10 to the third meters per second. And we know the mass of particle 1 is 6 times 10 to the negative 6 kilograms. So if we take a look, we're trying to find the charge on each particle. Remember, they're similar charges, so we're trying to find the charge. The only equation we know so far with charge is K Q1 Q2 over R squared. Remember, these are the same charges, so we've got K Q squared over R squared. Now we're given the mass here, and we're given the acceleration, so we should remember that F equals ma. So the mass 1 times the acceleration 1, which is the electrostatic force on our first particle, is equal to kq squared over r squared. So if we solve this right here, we end up with q squared is equal to m1 a1 times r squared divided by k. And as you go through that and you come up with your solution, we end up with a charge q squared equaling 2.07 times 10 to the negative 15 coulombs squared. And then as we take the square root of that, we end up with, let's see, we're going to have 4.5 times 10 to the, and we're going to have a negative 8. So 4.5 times 10 to the negative 8th coulombs. So the charge on each particle is 4.5 times 10 to the negative 8th coulombs. As we go through and find the mass of particle 2, well, we know that the electric force on particle 1 is going to equal the electric force on particle 2. So m1 a1 is going to equal m2 a2. So m2 will equal m1 a1 divided by a2. And as you go through that, we end up with a mass of 3.2 times 10 to the negative 6th kilograms. And now we should see real quick that because the acceleration of particle 2 was nearly double the acceleration of particle 1, we get a mass that is nearly half the mass of particle 1.